Okay, welcome to video 10.2. Here we're going to talk about solving quadratics, just extra practice with what we've already done. So I want to just remind you that those day one notes where we wrote out all the steps and everything that we do are going to be very helpful for this day of practice. So it's just an extra day of going over what we've already done. So remember, when we solve by factoring, we need to think about the ways that we factor. So what are those? Well, that's to start by looking for a greatest common factor first, always. Then look for factor by grouping, difference of two perfect squares or D2PS, and trinomial factoring. Now, those are the types of factoring, but when we talk about solving quadratics, remember that we see these words like find the roots, or the zeros, or x-intercepts. All of these things mean exactly the same. You're just looking to find when the equation is equal to 0, because that would be a y value of 0, which will give you the roots, zeros, and x-intercepts. So we have to get these in standard form first. So what I'm going to do over here is I'm going to move the negative 35 because I want r squared to stay positive, so I know I want to move this to the other side. So I'll add 35 to both sides. Then I end up with this 0 equals r squared minus 12r plus 35. Now in order to solve this, I'm going to want to do an x box. And that's because there is no GCF, it's not a factor by grouping, and it's not a difference of two perfect squares. So x box, PlayStation, product, and sum, I need to find the numbers that have a product of 35 and a sum of negative 12. So we have to think about the factors of 35 and which ones would have a product of 35 and a sum of negative 12. Well, I know that they need to both be negative since the product has to be positive, but the sum is negative. So I'm thinking negative 7 and negative 5. And remember, if you have trouble with those, you can always list out the factors of 35 and then go through to determine which ones are the right fit. Okay, then in the next step we get this 0 equals r squared minus 7r minus 5r plus 35. Then we do factor by grouping, and we look for a GCF in both. And I think in the first two, it's r. And when I divide out r, I'm left with the r minus 7. And then in the second group, I think the greatest common factor would be a negative 5. And I need to take out that negative so that it'll match the inside and give it a positive r. And when I divide 35 by negative 5, I do get negative 7, which is good because now I have that r minus 7 in both. So that's a GCF. I can write it out first. So I've got r minus 7, and then the leftovers go in another set of parentheses, which is the r minus 5. Now, this is the new step. We have to set up the t-chart to separate the factors. And once you do that and set each equal to 0, we can solve. On this left side, I'm going to add 7 to both sides so that r is by itself. So I get r equals 7, and then on the other side, I'm going to add 5 to both. And I get r equals 5. So those are my two answers. And now just remember that you can check in your calculator in one of three ways, actually. We can take our answers and plug them in place of r in the original. So in this case, I would put in parentheses 7 n parentheses squared minus 12 parentheses 7 n parentheses and see if I get negative 35, which we do. And then the same thing with the 5. 5 squared minus 12 times 5, and we do get negative 35. Remember that you have to check both because we need to make sure that they are both zeros to the quadratic equation. The other way is to go to y equals, put your r squared minus 12r plus 35 into y equals, and check the table to see if 7 and 5 are paired with 0. Or you can go on your calculator, look at the graph, and hit second trace in order to calculate. And then number 2 is 0 to find the zeros, and you have to go left bound, right bound, and hit enter 3 times to find that 0. Okay, so just remember to follow all the steps. We'll continue this tomorrow in class, but it's really just a review of what we've already done in class and from the previous unit. Okay, have a good night. See you tomorrow.